says for A, find the values of the position and acceleration when the velocity is 0. First thing we have to do is we have to find out when the velocity is 0. What do? How do I find the velocity equal to 0? I take my first derivative. Remember, the derivative of the position is the velocity. And by the way, velocity can be positive or negative. Speed, if you talk about speed, that's only positive. If you throw a ball up, it's going in the positive direction. When it comes back down, it's going in the negative direction. I'm going to take the derivative. Hopefully you've had enough practice with these. These are the easiest derivatives that we can use. I'm just going to write them out. This is going to be 6t squared minus 30t plus 24. All I did is I moved the 3 in front, multiplied it by 2, and then subtracted 1 from the exponent, and basically did the same thing the whole way down. The 8 is a constant, so it's going to go to 0. That's it. Now I want to find the values of position and acceleration when velocity is 0. Since this is my velocity function, I want to set this equal to 0. And I already can see that I can factor out a 6. So I am going to do that right off the bat. And then I'm going to factor t squared minus 5t plus 4 as t minus 4 times t minus 1. I have actually 2 places, which makes sense because my position is a cubic function. I could have 2 places where my velocity is 0. My velocity is 0. V of t equals 0 when t equals 4 or t equals 1. Now that I did that, I just need to first plug it into my position. I want to do y of 1 first. That's be my position. This is my position. Y of 1, I'm going to do this in my head. I plug in 1, I get 2, minus 15 is minus 13, plus 24 is 11, plus 8 is 19. Y of 1 is equal to 19 meters, and it could also be at 4. And since it says it's between 0 and 4, I have to deal with 4. At 4 to the 3rd power is 64. Minus 15 times 16 plus 24 times 4 plus 8. And I can do this one. 15 times 15 is 225. So this should be 240 plus 96 plus 8. 96 plus 8 is 104. 104 and 128 is 132. I'm sorry, 232. 232. So negative 8?
That's what I got.
All right. Not too shabby. So there's 2 places, one where the velocity is 0. One is when our position is at 19 meters, and one is when our position is at minus 8 meters. And I also need to find my acceleration. Okay. So we have position. We have velocity. I need acceleration. And acceleration is the derivative of my v of t. So a of t is equal to v prime of t which is equal to, and I'm going to just take the derivative. We found our acceleration function, and we want to find the acceleration when t equals 1 and t equals 4. I have a of 1 equals 1 minus 18, and a of 4 is equal to 48 minus 30, so that's positive 18. Okay, and this is meters per second squared, meters per second squared. All right, so I have my position, I have my acceleration, and I already know my velocity equals 0. That's how we found everything else. Find the values of the position and acceleration when the velocity is 0. We did it. Position and acceleration, there's two different places. We found them both. Use your results in part A to sketch y of t between 0 and 4 seconds. And this is 1, 2, 3, 4. So this is my function that I'm trying to graph. I know a couple of things. I know when t equals 1 and t equals 4, my velocity is 0. Remember, when I take the derivative of a function and I set it equal to 0, that gives me my maximum and minimum values. At 1 and 4, I have my maximum and minimum values. And I know my position is at 1. So at 1, I have 19 meters. So let's say this is 10, 20. I don't know how, I don't think I have to go that high. That's my maximum and minimum. Let's do 5, 10, 15, 20. 1 second, I'm at 19. And at 4 seconds, I'm at -8. So at 4, I'm at -8. Okay, so I found my maximum and minimum. I know when t equals 0, I'm at 8 meters, because here's my function that I'm graphing. So if you plug in t equals 0, you'll get 8 meters. So I know it's starting somewhere around here. And it's obviously going up, then it's coming down. That's my minimum value. And that's all I really care about, because I'm only graphing it from 1 to 4. And we can tell we have a minimum. Obviously, the minimum is at 4 because it's -8, and the maximum's at 1 because it's 19. The only thing I don't know is where it's going to cross the x-axis. And I don't think this is something we can do. No, we don't have the skill set at this point to be able to graph, to find the zeros for this function. We're just gonna make an educated guess. I know it's starting here, it's going up. Then here, that's the maximum. It's gonna start coming down. Yeah, I don't think we have the information that we need. We'd have to factor that y of t. That should be the sketch of my graph between 0 and 4. And it should go back up to infinity. So because this is a cubic function and it's positive, what we know is that it's going to go down on the left and up on the right. So if I were to continue this might be good. So obviously, we don't know anything about negative time, but if we did, it would go down like this. And since this is my minimum, it's going to come back up somehow and look like that. But we're only worried about between 0 and 4 seconds.